we're looking at your network hardware. So before we start, we spent a lot of time looking at this transmission level layer. Okay, so we looked at the medium between these three things, right? That's what our wide network was that we went through. We talked about the different cables and things that occupy this medium in here. So just a bit of a background. So if something was medium, what does that mean? What's the word medium talk about?
Do
you want to go?
Allowing two things to pass through something. I know what medium is in physics.
So you talk about Goldilocks, three bears. The one was just right. So no.
Medium.
It's like is it where it's medium?
Yeah. So what's a medium then? So if a medium, if this is our medium, what does that mean? If you look at these things in between.
Yeah, something can make it pass through something.
Yeah, it can be about a thing, but the word medium, if you talk about those three levels, the medium's like one in between. Yeah. The one that's just right, the one that's not too big, not too small, medium, the one that goes between. So we've spent a lot of time looking at these two. Today we're going to look at the switching and routing. That's primarily what we're looking at, and we're going to look at all the different hardware that sit in amongst that as well. Okay. Now there's going to be a little bit of an issue here because some things will overlap, but you need to understand the difference between all of these. So the first one's hubs. So we don't use hubs anymore. Okay, so what they are, if I was to simplify it, in our classroom here we have all of our desktop computers behind us. A hub would be different in the sense that at the moment we've got a network point for every single computer. A hub works a little bit differently by having one point, but you can plug multiple devices into the hub. Okay, so in this example here, we can have basically 4, even 5 connections into one hub, and that would plug into one single network point. Does that make sense? Yep. So in this case here, why we don't use hubs anymore is that when they get a message, they send the same message to every single device that's plugged into the hub, right? So it's completely inefficient, okay? And you can basically flood devices with the same message, but it only needs to go to one device. Yep, does that make sense? So hence why hubs aren't used anymore. We want specific messages to go to that specific device. A hub can't do that. It'll only put that same message across every device, okay? So we don't use them anymore. They are obviously cheaper, but the issue then is it depends on how critical the hub is in that network. Okay, so if there's in a school network, we would never use hubs. With all the classes that are happening in one time. If we had people watching videos on Google Classroom, Google Docs, all those things in between, and you've got all of these thousands of messages going out, it's completely inefficient to have a hub as that go-between. Okay, so everyone confuses hubs and switches, and I'll talk about the difference in a second. But our hubs are basically same message gets sent to every device that's plugged into the hub. We good with that? Yep. Sweet. Okay. So your switches are your next part. So I've put this PowerPoint on Classroom for you as well. Okay. So this is just to help you fill in the pages in there. So with your switches, and this is what we have at school. So all of our network devices, so our computers, access points that are up here, everything in between, they all plug into a switch. Okay, and why switches are particularly effective is that if there's a certain message that needs to go to a certain device, rather than every port in the switch getting that message, it gets sent to that one particular device. Yep. So much more beneficial. Okay, so much better than our hub, and because of that, we can actually get faster speeds between each device on the switch, rather than 4 or 5 devices plugged into one hub. All right, does that make sense?
Yeah.
Yep.
Did you say that slide was on Classroom?
Yeah, all the slides are on Classroom. All right. So our switches are far more common, and basically our switches uses MAC addresses. Okay, so I'll talk about MAC addresses in a little bit, but basically every piece of hardware on the network has a MAC address, and it's unique like an IP address to every device, but they are different. An IP address and a MAC address are different, and we'll talk about them in a second. Okay, does everyone get that so far?
Yeah.
Good? Yep. Okay, so switches, specific devices get the information. Hubs, all devices get the same information. Okay, cool. Okay, our routers. So these get confused at home with modems, and they partially overlap. So some internet service providers will give you a modem that have like parts of a router in it. Okay, so you, like for me at home, I've just got my standard modem, and I can connect, my 20 devices onto it, and without having a router. The only issue you have is that if you don't have a router, then the modem's got to process and has a limited bandwidth. It's got to take all the information from all those devices, right, and sort them out and basically pump it back down the exchange and down that way, right? So a router is better. So if you can connect all of your devices to a router, its sole job is literally to move information back to the modem and out. It's far more effective than doing it through the modem itself. Okay? So it's set up for it. And like I said in here, it's got small computing parts. So it's got a CPU and memory in it. And that's why a lot of your routers actually have software on there where you can actually log into your router, update any settings on it, maybe even put a firewall in there if you wanted to. And it even has a switch built into it to some degree as well. So if you're at home and you were setting up a real basic network, then you would have your modem, which would plug into your router. And if your router is wireless like this one is, and we can tell by the antennas here, then you could just connect all your devices to that one router. All right, providing you don't want to hardline any more than about eight different devices. All right, are you good with that?
Yeah.
All right, so if at home, you'd probably have modem into the router and then devices would be onto that router. If you needed more wired connections, then you would wire in a switch here. So you would plug a switch into this router, and then you would have your 20 other devices, whatever else you wanted to put onto that switch. That's how they connect together. Yep. So that's how that works. Yep, and like I said, these here work off IP addresses, so they route the information to the specific IP address. Okay? Yep, good. Okay, so your modem. So the sole job, like all of you know, is to provide your house with the internet. That's its only job. Okay? Some have routing abilities in it, very basic. Okay, but all it does is provide internet for your home. Okay? So it does have ports like a router. So you can see here that on this example here, there's a coax cable. So you can plug coax in the back of this one. We even have an Ethernet port for this one. And then we've got a power jack button and a reset. So for the basic home, if you only wanted to wire in one device, then that would be perfect. The only issue you would have, and this is speaking from experience, if you had a wired connection in there, so maybe my computer at home sits next to the modem, so I plug that into a wired connection from my modem into my computer, then I have my phone or maybe some of my consoles or whatever it is over the Wi-Fi. You might have issues with one being faster than the other, or one taking up more bandwidth than the other. Okay, so you've got to be very careful if you're just using your modem, because it doesn't really prioritize the wireless signal. It's all about what's plugged in first and then the other signal. So you do have some bandwidth issues if you're just using a modem and you're using a mixture of wired and wireless at home. Okay? So that's the basic there. We good with that? Yeah? Okay. So our bridges. Now again, like I said, computing is very simple. If we're talking bridges, what does a bridge do in life?
Allows you to connect to separate islands so you can cross over.
Great. So if I've got place A and place B, and I want to get to the other side, I need a bridge. Yeah. A network does the same thing. So with each of our LANs, so here we've got two LANs. So two LANs on one network here, got another two LANs on this side. The bridge literally allows that crossover to happen. Okay. So you can make many networks one seamless network. So for example, if we used our school, so if our school is one LAN, we know there's one LAN already, one area. Let's say we wanted to go to Magdalen, who's got its own separate LAN. We can actually connect a bridge, which would make both of our sites just one big network. Okay? So that's our bridge. So bridge is our go-between. So we can connect many LANs, and providing they have the same protocols, they work the same way, then this will happen without a problem. Okay, so what I mean by that is in our environment, we've got a mixture of Windows and Mac, so we have a bit of an issue there already. But if the protocols are a little bit different, then we need something that sort of be that mediator that can convert protocols in between, and that's what I'm alluding to next. Okay, so unlike routers, like I said, routers are an IP address. These bridges work off of MAC addresses. Okay, and the difference here between IP address and MAC address is that they work at different layers. Okay, that's the only difference between the two. So our bridges are looking at MAC addresses, our routers are looking at IP addresses. They're both the same in the sense that they are unique to each individual device, but they just work at different layers. I'll explain that a little bit later. Okay, but that's our bridges.
Okay.
Good with that? Yeah. So I don't think too hard. Literal bridge, two networks, lesson basically become one. Cool. Okay, so I'll put this slide in here as a difference between bridges and routers because a lot of people do get them confused. So basically they both work off two different layers. So one's a data link layer, one's at a network layer. Don't have to worry too much about that. But basically one uses frames, one uses packets. It's just working at different layers, but they do similar jobs. But bridges bridge the two networks together. Routers, they just deal with the network that they're in. Okay? Cool. All right. So gateway, this is what I was talking about before. This provides that communication to happen on two different networks that may use two different types of protocols. So our Mac lab up there in F2, right? They're all Mac, so they won't use a different set of protocols. So in this one here, this example uses Apple Talk as an Apple protocol, which might not work with TCP/IP, which might be for our labs down here. Okay, so we use a gateway, which can be software or hardware, and basically what it does is it provides that way for the two networks to talk. The translator, if you want to call it that. Yep.
How would it be hardware? Like, what is it called?
So it's just a gateway.
Oh, okay.
Yeah.
It's like a device.
Yeah. Very much it can some bridges, especially nowadays, some bridges actually allow for you to install like a gateway program onto the bridge, so that you can basically just have your bridge in there, so that they're two different networks. They'll just the two in one, and it works seamless between two networks.
Yeah.
That's one example as well.
It's just something that.
Translator.
It's just translating to
Yep.
different devices.
Yep.
Different software.
Yep. Different protocols. Yeah. Right. So bridge, physical bridge takes two networks. A gateway can be software or hardware that allows two different networks to speak two different languages, right, or different protocols to work together.
We use a gateway here?
We do have some, yeah.
Is it hardware or software?
It is a software. Sits on our router down the comms room. Yep.
Okay.
Cool with that? Yep. So that's our gateway. So that's it. The ones that are left in your book, things like network interface cards. Yep. You all have them. Most of your laptops will have them. It is.
Yeah, my laptop has.
Yep. So that connects that port where you have a wired connection, which allows you to plug into an Ethernet cord, an Ethernet cable, sorry. Then you have a network interface card. That's there. That's there for you to use. You can use that to plug in via a wired medium. We good with that? Yeah. That's a quick crash course. Okay, but that's what they all are. Today's part of your quick quiz. I've given you examples out of past HSC papers that ask you to identify different types of network hardware and when you would use one over another. So it's definitely worth writing down. Then the other ones I haven't gone over in your book, things like mobile phones. You know what they are. We've talked about them and how they use cell towers. Yeah, they pick up your phone in one particular region and then transmit to other towers to where the other person is that you're making the call with.